Hello, everyone. I'm kind of excited to be here for many reasons. I always like speaking, near my house, and I live in Poland, so that's been quite exciting journey yesterday, 3 a.m. in the night. Um, okay, so before we start, just a couple of words about me. Thank you for warm introduction. That really means a lot. It is true that 3 years ago I gave the very first talk about React Native in Prague. That was the Web Expo conference. And I was talking with someone that you may know from React, Daniel Steigerwald. He speaks a lot about immutability and stuff like that on Twitter. And we've been trying to sell the concept of universal React to people by then. And I actually took it forward because 3 years after, I'm working at ColdStack, which is a company I co-founded that has the same mission to kind of create cross-platform code for clients, developers, and help them launch their products for everyone at the same time. And also, I'm a core contributor to React Native, and I've been kind of working on CLI for a while. And these days, I'm mainly responsible for doing releases of the open source version. So if you are following React Native, you probably see me tweeting, once a month about the new release and trying to get things up and running. So that's what I kind of do. You can see my handle on screen, so if you're interested in more updates about React Native, that's a good moment to go and give me a follow, if you don't mind. So back to our topic. Before we start, let's get a better understanding of our background and where we are coming from. So please raise your hand if you are doing any mobile experience right now at your company, either React Native, Cordova, Native App, whatever that runs on mobile. All right, so that's quite a few people. And how many of you, I guess everyone, is doing web development, right? Yeah. So as you can see, the truth is that most of the people within our community, and I'm here specifically talking about React Native community, which is a subset, are coming from web development background, with React being the most popular framework amongst them. And in fact, that's my personal belief. React is what makes people to actually go and consider React Native. Because without it, all its benefits starts to water down, and actually you start thinking like, are these red boxes and issues worth it? Because you can go natively, right? And with our background, we carry something that I actually named WebDat, being inspired by technical debt, is a set of best practices and standards that we learned over time while doing web experiences. So back in the day, we started writing static pages. Then we added simple animations. We've been doing single page apps with Angular, and then we are most likely now working with React or maybe Vue.js. So that's our experience, that what defines our proficiency, right, in the industry. That's why they call us JS or software developers. Probably a lot of you are here like senior developers or maybe are helping your colleagues that are just trying to learn React. So that's what we do. So why it's actually a wrong thing? Because that is like a not positive word. The reason is web and mobile are fundamentally different platforms, and they have different expectations and interactions. And the former one uses mouse as a pointer device, right? Is available right away for the user, and has to paint real quick for the user to stay focused, right? We've seen all these tests saying that if you don't show anything right away, the user can close the tab. So that is partially the reason why websites are so, let's say, rough, and they don't have a lot of animations. And every time, often when you see a website that has a lot of animations, you are like, oh my God, this is bloated, it's slow, it's kind of turning all the fans of my MacBook, which happens all the time. And every once in a while, I'll see this article on Twitter saying like, oh my God, these guys hijacked scroll position, please don't do it. So it's like one of the reasons why these things are the way they are. So one thing is that our users are expecting our websites to be that way, to be quick. And the other is that complex animations and transitions are fundamentally different and harder than on mobile. Because unless you are working on a game, promo, or a highly interactive project, the animations that you will be working on are most likely focusing on transition between two states, right? So either you hover, for example, imagine you hover a link. There are two states, right? There is the hovered link and then not hovered. Like there is no state in the middle, right? There is no semi-hovered link or something like this. So that's the transition on web. Like we have start and the end. However, mobile is different. It's gesture-driven, right? And users expect high-quality experience from you. Every platform has its own expectations and set of constraints, right? Like iOS has its, design guidelines that are famous for being very, very specific about every single part of the app. And Google has the material design. And that not only describes things like fonts and colors, but also, how to even animate stuff on screen. And for many years, iOS has been famous for the smoothness, like I said. And just like on this example, majority of apps that ship to the App Store are highly interactive and actually bound to the touch events. Like in this example, the gesture is actually directly bound to your finger as you scroll up. So you can actually do whatever with it. You can stop it, you can reverse it, you can maybe drop it and see if it goes, if it has some velocity. So it's way more than just two states. And it would take us a while to discuss why all these differences did happen. However, I think there is one fundamental thing that makes up this huge difference, which is, in my opinion, the APIs. Because on mobile, it's just easy to create native, fast, and hardware-accelerated animations from the very beginning, right? And if you are working for a company that does software for others, the case is very simple, right? If something is not easy and quick to do, you most likely are not going to pitch this idea to client because everyone wants everything for yesterday. So these sort of things are also the answer. But thanks to React Native and the animated API that he has, and I'm going to be talking about it today, that the patterns of mobile can be embraced from iOS to Android and even to web. Because unlike mobile, web didn't start with the best APIs first. Like we had Flash, and I'm saying this, but when we had Flash, I wasn't actually doing software, so I'm just basing this on historical readings. Yeah, and then we had CSS animations and keyframes, and when we've been doing something along these lines on screen. Imperative code, focus on event, and then you were focusing on an exact interaction that you want to do. So in this case, you want to slide toggle the menu as soon as something is clicked. So this could be also a hover and some other sort of animation. And if you are like me, that's where you started your web development career. And for many years, I've been like this child on this GIF, solving animation problems step by step through the eyes of imperative development. It worked quite fine throughout the project life cycle, just to sort of, fail at the end. Yeah, I'm sorry for him. That's the thing, like, this approach looks good at first, and it's like, oh yeah, I can slide toggle this menu in like 1 minute, but then as you add all the states that we've seen on mobile example, it's gonna be, pretty hard to do. And then the thing is that if you started when this was the thing, like me, I was surprised that there were other ways of doing stuff. Like, this imperative approach was so natural to me that I was surprised to actually understand how React can render and how the animated API looks like, which took a while. And that's the web that we carry over and over every day. And we just made the first step, we got aware of it, so that's good. And it's not just about doing animations one way or another. It's about exploring, what impact our platform that we started our journey with can have on our mental model. So for example, think about object-oriented developers that are asked to write Haskell functional programming code. They will have troubles understanding concepts for the first time because they think in a totally different world. So once they get used to the new reality and new paradigms, they will start thinking, okay, how could have I done these classes and stuff like this because the functional programming is so good. So the same happens with the mobile and web stuff. So let's see how to overcome these issues, especially in context of React Native. And since there is no better explanation than code, we'll have some nice examples, and I'll be using Snug. So now, if you haven't heard of it, it's a CodePen-like platform where you can create your React Native app in a cloud, you can run it, you can save it to your device, or you can share it with your attendees if you are on a meetup or a conference like me today, which is good. And every code that I'll be showing you today is going to have a corresponding Snug URL, so after I'm done and I'm going to publish my talk, you can go ahead and check what I did there. And please don't pay attention to super details, because I was focusing on the general concept. But since I didn't pray to demo gods, I'm not gonna be live coding. I pre-recorded things in the morning, just because you never know what's gonna happen. So what we are going to build, like, I've been thinking for a while, what could be a perfect example to show you the differences here, and I think this is pretty common. This is pretty common layout these days. The header, as you scroll, it changes its height. It collapses up or down depending on the app. So how do we go about implementing this? So the first thing that comes to our minds is to listen to scroll events, right? Capture the new position and tell a header, okay, change your height. And that's what we would do back in web, like, right, with jQuery. That would be the first thing I would genuinely do. And I'm not sure if there is any other way I would do it these days. So let's go ahead and check it out. So first, a small boilerplate code. I'll start with defining an array of images, because I'll be showing some images in the list. So this is just for reference, so you know where they are coming from. It's a random unsplash generator that can give you some nice results. And then I'm going to create a sample app component. This is a React component. The component is imported from React namespace. It has a state header height 0, because that's the initial state, which is obviously causing small glitch that I never actually caught, because if you launch the app and the header height by default is 0 before you scroll for the first time, it's going to be blank. So that's one example why not do this approach. And so then what we're going to do is we're going to go ahead to our render method, and we're going to define the view. The first one with the height and the background color blue is something that you can call a header. It's gonna be kind of mimicking the header container. And the scroll view is something that will be kind of a list view with the items. I'm gonna be using scroll because it's just easier to see on the code. And there is that onScroll prop that I can use to listen to scroll events. So I'm gonna go ahead and do this handle on scroll, which is going to do nothing exciting, but just calculate the header height of the existing offset. And the offset y is the number where the offset of the scroll view is on the vertical axis. So this is how it looks like. As you can see, it's sort of okay, right? The header changes as you scroll. But there is one thing missing here. Not all the states were implemented. And for example, like, if we scroll down here, if you scroll up, the header disappears, right? Because we didn't handle the case when the header height is negative. So we have to go ahead to our handler code as here and sort of do the guard if the height is smaller than 20 pixels, which is the status bar height. Just take it, otherwise take whatever you have. And the new example is going to be sort of, more or less working the way we are. So the question is, are we done yet? Are we done here? Yes, it works, and no, it's not future-proof. Although this approach works, it's kind of baggy. And I selected this particular interaction on purpose just to show you that you can do it, but you shouldn't, because at the end of the day, it will leave you with a lot of hard problems to fix, and the states that you will be handling will be adding up. And what will happen is you will end up with 5 if statements like this in your code, and a year after, you will come back to this code base, and you will be like, what I wanted to express by this if statement. And it actually happened to me when I was preparing this talk, and I had to go over to the code that I'm showing, and I was like, what's wrong with this? Like, what I wanted to do there. And there are a few more issues with performance being the most important, I guess, here. Because by doing things imperatively, just like with React, you kind of opt out from optimizations. And so if you tell the framework, especially in context of React Native, to go every single scroll update and update the view, you will going to kind of cause a lot of traffic on the bridge. And bridge with React Native is something that connects the JavaScript with the native side that actually controls the appearance of the app. So it has limited capacity. So imagine the case that the onScroll callback that gets called, it's already async, right? Because you scrolled, but the moment React Native gets the value, it's no longer the exact position. It's like a few points off because it happened like a millisecond ago. So if you start animating asynchronously your header, you do it quick, it will be like a mess, like a floating header, which is not something that you want. And you can't do this natively, because how you can do it natively if you do it yourself? But fortunately, there is that parallel universe where all the things are functional, and they leak this concept of interpolation, which is kind of easy to grasp. So, so a question: how many of you have ever used CSS-free keyframes? All right. So you guys have a better starting point because this is sort of the same. If you didn't, and you want to do similar thing to what I'm showing you on web, CSS-free keyframes are sort of the same as far as concepts and the mental model. So what is interpolation, especially in context of React Native? So instead of telling your view to update itself when something happens, like a scroll, you describe how it should react to updates and let the framework handle it for you. And that's very important, the static nature. The static nature is super important here. It's not the fact that it's declarative. It's the fact that you precisely know before the app runs what is the relation of the animation over time. So just to see the example revisited, instead of having the header height, I'm going to have this scroll value to kind of, it's like an animated.value. It's from animated library. It's a placeholder for number that can be interpolated and is holding animation values. In this case, the initial value is 0. And then instead of an on-scroll handler, I'm going to use this animated.event. It looks very, very cryptic to me. And to be honest, like after a year with this API, I still don't know what's first object or an array there. So it's, if you are confused, you are not alone. Anyway, what it does is it maps the content offset y property to the scroll value that we have on state. So that happens automatically. And then the last thing that I'm doing here is I'm basically interpolating the value. So I'm saying basically that for the 0 offset of the scroll, your header should have 200 points. And if the scroll offset is 300, my header height should be 90 points. And the extrapolate clamp basically tells the interpolation you shouldn't actually go beyond the boundaries, because if you don't set this and you scroll down, 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 it will be like trying to, kind of make the curve of the animation longer and go forever as you scroll. And this is how it looks like. This is how it looks like in action. As you can see, it's slightly different because quite a few things did change there. But it's sort of okay because I've been able to replace all these if statements with just a simple interpolate that kind of is future-proof and easy to understand as long as we are familiar with animated API and what interpolation is. And to be honest, a side note to this talk is that when I started doing animations, I was like very lost because for a non-native speaker like me, understanding what's easing, what's interpolation was like very hard. I was like, I don't know what this documentation is saying because for interpolation, it's like interpolates the curve over something like this. I was like, I don't understand this. So so it's also good to read some vocabulary before and maybe some math if you are really excited about animations to exactly know what's going on. And that's the real beauty of React Native, the fact that it uses declarative approach everywhere, even in places that I never thought that it could have been used. But okay, the talk was titled "The Power of Interpolation, Not Understanding Interpolation," right? So what's really that powerful in interpolation itself that makes me so excited? So in almost all cases, animations, as we've seen, are actually done as a response to gesture, right? You scroll, you touch, you interact with the screen, something changes. And that's, for example, what happens with a scroll view, right? You interact with the scroll view, there is the on-scroll, and things just animate. So in today's case, as I said, we used animated.event to kind of bind this event with the scroll value on state. So in other words, gestures are just yet another input source to animate it through the animated.event. And turns out pretty much anything can be an input. It doesn't have to be a scroll position. It doesn't have to be a gesture. As long as it's a number that changes over time, you can interpolate this. And to give you a perfect example where it makes total sense is the media player. I don't know why, but for past 2 years, I've been lucky enough to build 3 media players with React Native. And these things are like one of the craziest things in the world to create. Not just because the UI has to be in perfect sync with the playback, but also you have to make sure that the UI is snappy and all the things are laid out properly on screen and there are no glitches, and things like when I was writing this app, I had to study Spotify use cases and see that if you press, for example, backwards twice, it should go backwards, but if it's like longer delay than 5 seconds, it shouldn't. So it's like a lot of weird states to handle. And this one is hard in particular, as you can see on screen, because it's for singers. So when you sing, it scrolls horizontally. But the problem is, the standard media player app has the linear progress, because the progress is like every second, so it's a linear curve. This is not, because you can change faster or slower, it can change over time, the tempo is crazy. And this particular client came to us because he already had app in the App Store, but the problem was they couldn't complete all the features. And it was, what was the fundamental thing they did wrong? They made the code imperatively. And it ended up being impossible to maintain and to kind of add new features on top. And I gotta say, my mind was blown when I heard this request, because I was like, is this the first React Native project I will have to genuinely say it's not a good fit for React Native? I really wanted to be challenged here and see whether we can do it. So my standard, let's say, algorithm for doing these things is to start small with the smallest subset of the system. And what's the smallest subset of the system of the media player? The native player itself, right? So I called this component the player. And I found a lot of things in common with a scroll view, because just like scroll view has on scroll, which is the offset, the player could have the on progress event that calls the point in a song. And the last part was just to figure out how to move things on screen, because this is okay, right? I get the playback of the song, but what can I do next with this? And since the player component was sending me bug events to JS, I thought the playback could be just another input for the animated value. It starts with 0, because 0 seconds is the start of the song, right? It can end with a random integer like 300, which would be like 2 minutes or maybe 4 and something like this. So that was the light bulb moment for me. Duration can be interpolated. I could define the static relation of any song in time up front, and I could have tested that without even running React Native app, because I can generate the interpolation object before even going into that view that is displaying that, and I can test very, very complex interactions, which makes this extremely helpful for things like this. And since this is a bit cryptic and advanced, let me quickly show you the live recorded demo from the morning, how the playback looks like, and then I'll show you the code itself. So I'm gonna hit play, and as you can see, the notes are highlighted, the tempo is sort of changing, and I can hit it and I can pause it anytime, I can go forward manually, I can go backwards, and the entire UI is staying in sync. And hundreds of issues are gone away, like hundreds. Just because everything is bound to the interpolation, I don't have to think, what is this user going to mess with my app if he's scrolling? Or maybe what happens if someone, like a good case, like a few weeks ago, we've been implementing interruptions. If I'm singing and someone is calling me, I want to stop this. So all I had to do is I just had to stop sending progress events from native side and nothing else. Like nothing else, like I don't even have to think about it from JS realm. So that is really, really, really exciting thing to do. So let me try if I can quickly unplug myself somehow, and yeah. This is definitely way more trickier than I thought. Actually, I think I have to turn off. How many minutes we got? All right, so let me quickly see if I can. I think I have to turn off screen mirroring for this to work, which is okay. So I'm not sure I can do it. Anyway, I've prepared these two files, so it's gonna happen. So don't worry, it's gonna happen. Someone is using Visual Studio Code. Oh, this one is better. Oh, that was a good click. So as you can see, here's the player native in a wild. It has exactly the code that I showed you with the onProgress, which is the progress animated updater, which is nothing but just the animated that event that I moved elsewhere. The exciting thing is, which is actually happening here, I have this player renderer that I showed you, which is just that horizontal scroll view timesheet. And the important thing is happening here. The web view style, because yes, I'm rendering SVG in a web view. It's not a bad thing. And I have this transform here. Translate x margin left. And margin left is interpolated property. And I'm using transform just because I'm offloading that entire animation to the native thread. So every animation that you just seen is fully native. Like it's React, but you can do pretty much whatever, and it's like 60 frames per second. It's faster. It's like fluid as you know, like on Android. So you should try this out. And here is the same thing for the red bar, the bar offset, which is calculated exactly in the same way. So I'm not gonna show you the details of build interpolation because that's a lot of internal to this project logic. But as you can see, I'm just calculating that given the nodes. So this player is quite simple. I just have an array. I know at what time in song nodes should be highlighted. So I just calculate the curve between different timestamps of a song. I know it may sound really crazy, but it's not. And it shows that you can do a lot of cool things with interpolation, just like players. Good. When I'm doing this, I'm always scared my speaker notes will pop up there and the slides here, so it's good. So wrapping up, like that's the real beauty of interpolation, It makes things easy that would have been extremely hard otherwise. Yet it's still super easy to debug. Like when I discovered that I can use media player and interpolate it to do this, like I couldn't believe myself that I'm right. I was like, this is too easy to be right. There has to be a catch somewhere. Probably I'm going to realize tomorrow that this is all going to burn because I can't make it. But yes, you can do it, which is crazy. Like, it's crazy paradigm that is going to change a lot of things as far as what we do. So what I want you to do is I want to encourage you to think of animations that you're working right now with your app. Think of them. Think of any performance problems that you might have. And see whether this pattern, the pattern of interpolation and the power of interpolation, could help you deliver better performance. Thank you very much.